Operation control of multi-unit systems has a big impact on their energy consumption. Modeling those systems in hourly or sub-hourly intervals over a full year, with operation control in mind, can be costly and time-consuming. CogenS offers a quick and simple way of modeling multi-unit chilled water systems without losing the needed accuracy of operation control. Here we are starting the project by using a combination of methods 3 and 4 to estimate the building energy consumption profiles. First, we call for the electricity, heating, and cooling reference profiles API using method 3. Then we choose method 4 and import the actual monthly energy consumption data that we already have for the building. That way, the reference profiles called from the API are scaled on a monthly basis to match the actual building energy consumption. Once we're at the Cooling tab, we can start modeling our chilled water system. Selecting between air-cooled versus water-cooled chilled water systems depends on many factors, some of which are capacity, maintenance, efficiency, and part load performance. In this example, our calculated peak cooling demand is 245 tons refrigeration. By adding a 15% sizing factor, the design system size should be at 280 tons. Now we could use one unit, sized at 280 tons, or we can use multiple units, sized at a lower value. That will depend on the minimum unloading ratio and the part load performance curve of the unit. When looking back at the cooling load duration curve, we see that the load is higher than 50 tons for more than 5,000 hours, so we need to choose units that operate at high efficiency when serving loads between 50 and 250 tons. Here we are using two air-cooled chillers sized at 140 tons that operate at great efficiencies between 30 and 90% part load, which equates to 42 to 125 tons. That's great performance for the operating range we are looking for. It is worth mentioning that CogenS will automatically populate default performance curve data and other values for typical equipment types as we select them. The user has the option to change the defaults and explore different design options for their system. Finally, we click Calculate in the Tables tab, and the model is done. To make sure that the system was operating at the intended efficiency range, we can calculate the annual average coefficient of performance of the system by dividing the total annual energy consumption by the total annual cooling load, which gives us a 4.1 average coefficient of performance throughout the year. During the modeling process, CogenS decides the optimum number of operating units at any given time step to maximize the unit operating efficiency based on the part load efficiency curve. If you like this video and looking for a one-on-one demo of CogenS' other features, please reach out to us at info@jisenergy.com. Stay tuned for more videos like this on our website and YouTube channel.